Question 7. The attendance at the Ireland versus Romania game in 2015 Rugby World Cup was 89,267. Part A. Hugo rounded 89,267 to the nearest 10. Write down Hugo's estimate of the attendance. So RD stands for rounding digit. So if he rounded to the nearest 10, then the 6 is the tens. So what we do is we go to the number directly to the right of that, and that becomes our rounding digit. So the rule is 5 or more, let it soar, 4 or less, let it rest. So 7 is 5 or more, so the 6 is going to round up to 7, and then the 7 just becomes a 0. So we get 89,270. So since this 7 was greater than 5, we let it soar, we let it go up. The 6 goes up to 7, and the 7 gets replaced with a 0. Danny rounded 89,267 to two significant figures. So significant figures are non-zero digits. Write down Danny's estimate for the attendance. So if we're interested in two significant figures, we have to go to the third significant figure, which is going to be 2. So this is going to be our rounding digit. This will tell us what will happen to the number in front. So again, 5 or more, let it soar, 4 or less, let it rest. So since this 2 is part of 4 or less, the 9 is going to rest where it is. It's going to round down, but it's actually going to just stay where it is. So we get 89,000, and then we just add in the 3 zeros. So any of the other digits get replaced with a 0. Part C. Jenny rounded 89,267 to 89,300. Write down Jenny's estimate in the form of a times 10 to the power of n. So this represents scientific notation, where a is greater or equal to 1 but less than 10, and n is an element of n, so n is a natural number, a positive whole number. So we write out the number 89,300, and we put a decimal point at the end. And what we're going to do is move our decimal point as many places to the left as we have to until it's just after the first digit. So we move it 1, 2, 3, 4 places to the left, and it goes after the 8. We can get rid of those zeros. And it's going to be times 10 to the power of 4 because the decimal was moved 4 places to the left. If we had moved the decimal 5 places to the left, it would be to the power of 5. If we had moved it 6 places to the left, it would be to the power of 6, and so on. Question 8, Part A. Multiply out and simplify x plus 9 times 2x minus 1. Part B. Factorize fully 3ax plus ay plus 3cx plus cy. So what we're going to do is notice that we have 2 eggs, and we're going to crack open the first egg. So we're going to put our crack in there in between the x and the plus 9. So we're going to bring the x down here in front and stick it on to the second egg, which we did not crack open. We're going to bring down the plus 9 and again stick it onto the second egg, which we did not crack open. Then we multiply out the brackets. X by 2x is 2x squared, x by minus 1 is minus 1x, 9 by 2x is plus 18x, 9 by minus 1 is minus 9. Then we're going to add or subtract the like terms. So 2x squared comes down here because there's no other x squareds. Minus 1x plus 18x is 17x. And then we bring down the minus 9. And that's our answer. And here we have a quadratic equation, which is a U-shaped graph. Part B, factorize fully. So since we have 4 terms, we're going to factorize the first 2 terms and then factorize the second 2 terms. So what is common to 3ax and ay? Well, clearly there's an a common to both, so that comes outside the bracket. That's our highest common factor. A into 3ax, well, the a cancels and you just bring down the 3 and the x. And a into ay, the a's cancel, so you just bring down the plus y. Then we're going to factorize over here, 3cx plus cy. Well, what's common to both? We can see there's a c common to both, so we take that outside the bracket. C into 3cx, the c's cancel and we bring down the 3 and the x. C into cy, the c's cancel and we bring down the plus y. Now we notice we have 3x plus y in both sets of brackets. So 3x plus y is one of our factors. And then a plus c is our other factor. Question 9. Ned and Laurie had a race. Laurie was given a head start, so she ran a shorter distance than Ned. The graphs below show the distance along the track in meters that each of them was from the starting line after t seconds of the race. So our x-axis here represents time in seconds. 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, and so on, up as far as 12 seconds. And our y-axis represents distance along the track in meters. So we start at 0, we've got 5 meters, 10 meters, 15 meters, 20 meters, 25 meters, 30 meters, 35 meters. So this is where the starting line is, obviously at 0 meters, and this is where the finish line is at 30 meters. So this is Laurie. She started at 5 meters, she got a head start, and Ned started at the very start, the starting line. So that's Ned's graph there. Part A. What distance did Ned run during the race? So part A, what distance did Ned run during the race? So this is Ned's graph here. I've highlighted it in yellow. So he started at 0 and he stopped at 30. So from 0 to 30, there's a distance of 30 meters. Part B, what distance did Laurie run during the race? Well, Laurie started at 5 meters because she had a head start. And she also ran the full race, which ended at 30 meters. And from 5 to 30, there is a distance of 25 meters. 30 minus 5 is 25, so she ran 25 meters. How many seconds did it take Laurie to finish the race? So again, this is Laurie's graph. I have it highlighted in yellow here. And this is where she finished. This is where she got to 30. That's where she finished. So if we drop a perpendicular down to our x-axis, we see it took her 10 seconds to finish the race. Work out Laurie's mean speed, so average speed during the race in meters per second. So Laurie travelled 25 meters in 10 seconds. So we got the 25 meters from over here. 30 minus 5 is 25 meters. And she did it in 10 seconds. So we're going to say 25 divided by 10 is 2.5. So her mean speed is 2.5 meters per second. So whenever we are trying to work out distance, speed, or time, we're going to use Dad's silly triangle. And what you do when you're trying to figure out distance, speed, or time is you use Dad's silly triangle, and whatever you're looking for, in this case we were looking for the speed, you would put your finger over the S and you would see that you were left with D over T, which means distance divided by time. So you'd put your finger over the S and you're left with distance divided by time. So that's how you work at the speed. If you wanted to figure out the time, you'd put your finger over the time and you're left with distance divided by speed. And if you wanted to figure out the distance, you'd put your finger over distance and you're left with S and T stuck together. And two things stuck together in maths means multiply, so it would be S multiplied by time. So speed multiplied by time would give you the distance. But in this case, we're looking for the speed, so we put our finger over the S and we're left with D over T, which means distance divided by time. So that's what we did. 25 divided by 10 was 2.5 meters per second. Part E. Ned says, I ran at the same speed for the whole race. Is Ned correct? Give a reason for your answer. No. His graph is not a straight line, so his speed, which represents the slope, is not constant. It's not the same. We can see that his graph is a curve. If it was a straight line, it would mean that he was running at the same speed the entire time, but it is not. It is a curve, so he runs at different speeds.